Hi, everyone. Today we're going to talk about properties of sound. Section number 2. Things I want you guys to focus on today is how fast does sound travel, and how are frequencies and pitch related? How are loudness and amplitude related? So, first thing I want to talk about is how fast sound travels. Now we've heard of, sometimes we have jets and things that can break the speed of sound. A bullet can break the speed of sound, things like that. But the speed of sound will travel differently through different mediums. So suppose you are standing at one end of the pool. You hear two people from the opposite end of the pool yell at the same time. You hear their voice at the same time because the speed of sound depends on the medium in which it travels. So you hear them at the same time, even though one person is louder. Why is that? Now, one thing you can think about is back when I ran track in high school, they'd have us time things. And if you ever go to a track meet or if maybe watch the Olympics, you will see the smoke when they fire a gun. You'll see the smoke before you will hear the sound. And why do you think that is? So why do you see the smoke before you hear the sound? And the reason is because light travels faster than sound. So you'll see it faster than you will hear it. Okay, so it travels at different speeds. The speed of sound depends on the state of the medium. Sound travels faster through solids than through liquids or gases. The speed of sound also depends on the temperature of the medium. Particles of cool materials move more slowly than particles in warmer materials. They also transmit energy more slowly than particles in warmer mediums. Therefore, the speed of sound is slower in cooler mediums. And you can think about that as there's more energy in heat. When we talked about thermodynamics and things like that, there's more energy in heat. So if you take a look at this, at air at 0 degrees Celsius, we have a speed of sound at just 331 meters per second. When we get up to an air at 100 degrees Celsius, now 100 degrees Celsius, now remember that's boiling, so that's 212 degrees Fahrenheit. Our speed of sound is now higher. So, but now if you look at water at 20 degrees, we're at 1,482 meters per second. That's why sonar and things like that in water, we can hear those things. They travel a lot faster. It is possible to move faster than the speed of sound. In 1947, pilot Chuck Yeager was the first person to fly an airplane faster than the speed of sound. He flew high in the atmosphere where the temperature of the air was very low. So if you see that, the higher you get, the slower the speed of sound is. So let's take a look at our reading checks here. We take this reading check. Identify the speed of sound is faster in what two medium states? So is it faster in water? Is it faster in steel? Well, if it looks right here, if we take a look at this, the speed of sound travels faster in steel than it does in air and in water. Okay, the next thing we're going to talk about is how pitch and frequency are related. The vocabulary pitch. The pitch of a sound is how high or low. So like a person that has a high voice or a person that has a very low voice. How are they related? The pitch of the sound depends on the frequency of the sound wave. The frequency of the sound wave is the number of compressions and rarefaction produced in a certain amount of time. Frequency is often expressed in hertz, and we talked about hertz as in how many waves go through in a second. A frequency of 1 hertz is equal to 1 compression or rarefaction per second. So different hertz have different sounds. The more hertz it has, the higher the pitch. Whenever you see somebody come in to maybe tune your piano, if you have a piano, they have these little tuning forks, these little tuning pieces that, well, they can hit and listen to and set their piano to that tone because that frequency, it doesn't really change. So frequency and hearing, so you can see that a high pitch here has more compressions and rarefactions, and a low pitch has not as many waves. It's a lower wave. Humans, like animals, can only hear sounds with certain frequencies. For example, a dog whistle produces a sound with a higher frequency than humans can hear. Therefore, dogs will respond to the whistle. Sounds with frequencies too high for people to hear are called ultrasonic sounds. Ultrasonic sounds. you take a look at your reading chart, it says, what are sounds with frequencies too high for people to hear called? Now, there is this actual website, and I used to do this when we were in class with kids, is that the older you become, the less high frequency sounds you can hear in your ears. I know most of you have sat through those hearing checks that you've had in the nurse, and you'd raise your hand when you hear the high pitch and the low pitch. Well, as you get older, your ear muscles tend to lose some of their strength, and you can't hear the high pitches. And there's actually this YouTube site where I would put it on if we were in our classroom, where I would turn this high pitch sign on, and you guys would be like, "Oh, my ears," and I wouldn't even be able to hear it at all because I'm older than you, obviously, and my ears can't hear that high pitch. Another thing we talk about is the Doppler effect. You've probably heard the pitch of a police car's siren change as the car passes you. When the car is moving toward you, the siren seems to have a high pitch. When the car is moving past you, the pitch seems to drop. This change in pitch is called the Doppler effect. The Doppler effect is the change in the pitch of a sound you hear that is caused by motion. If the source of the sound is moving compared to the listener, the pitch seems to change. So sometimes you can even hear that when you spin something, you can hear the woo, woo. Okay, think again about a police car. When the car is behind you, both the sound waves and the car are moving towards you. Therefore, the compression and rarefactions of these sound waves are pushing closer together. The frequency pitch seems to go up. Remember, the waves are closer together, so the sound is going to be higher. After the car passes, it is moving in the opposite direction from the sound waves. Therefore, the compressions and rarefactions of the sound wave are further apart. The frequency or pitch of the sound seems to go down. The figure on the next page shows how the Doppler effect works. Let's take a look at our reading check number 4. It says, describe what causes the Doppler effect. Now, the Doppler effect is caused by the moving of those sound waves. So when they come closer to you and then when they go further apart. So as the wavelengths change, the sound or the pitch or the frequency will change with it. So here's what we're talking about here. So here's the kid sitting right here. See how the waves are getting closer to him? So it's a higher pitch. And when it goes past, the waves are getting further. So that makes it a lower pitch sound. Makes it a lower pitch sound.